Welcome back to part 5. We're going to get started on making enemies in this one, and we're going to get started on making a basic form of the damage system. We'll get a lot of the initial stuff kind of set up here with the damage system, and I'll just basically show you how making a basic version of it works and just the kind of core principle behind it. And that's pretty much all we're doing for part 5. And we are going to expand a little bit on it next time, so pay a lot of attention to this episode and make sure you're following pretty closely. Okay, other than that, good luck. Okay, so on to enemies and damage calculation. This should be fun. First, I'm just gonna undo some of the goofy stuff I did from the last video. So goofy of me, so funny of me. And I think I said I wanted to kind of take that down to 80. Anyways, we're done with this. You can mess with that stuff however you like. And now let's create an enemy. Okay, so I might just go ahead and create a new group. So right-click, create group, and I'll just call this enemies. I'm gonna put it under the player, and I'm gonna color this red because enemies are bad. Okay, so let's create a little placeholder for one of our enemies. Call this S enemy. You know the routine by now. I'm gonna make this enemy like a purple color. I'm gonna do a 16 by 16. I'm gonna draw a little skull to know he's bad. Okay. All right, hold on. Okay, so we kind of got a skull face now. Let's go up to image, auto trim all frames. You know the deal. Check and make sure the collision mask is appropriate. And then we can really put the origin anywhere. It doesn't matter, but I'll just put it in. I'm going to put it at the bottom center since that's where our players is. Remember, at the bottom between the feet. And at some point, we're going to make an actual sprite for this enemy. So let's just kind of simulate how it would work now. So we got the sprite. Let's make an enemy object. So I'm going to go to create an object. Now we're going to call this enemy, obviously. Let's go ahead and set it to our enemy sprite. Cool. And let's open up create event. We're not going to have our enemy move around or anything yet. First, what we want to do is let's get the damage working. So we're going to make an enemy that will do absolutely nothing, but it can run out of HP and die. So first, let's just set a variable HP, and we'll set it to, let's just say 10. Excellent. Now we can add our step event. And first, let's say receive damage. And we know we want our bullets to damage the enemy. But if we think ahead a little bit, we probably want other stuff to damage the enemy too, right? Maybe you have the video game classic exploding barrels, which we are going to add, by the way. So when we add something like that, and we add the explosion object that's supposed to deal damage to the enemy and to the player, we don't necessarily want that to be a child of the blue bullet object. So before we check for any damaging objects, let's actually create a parent object for things that can damage the enemy. So I'm just going to create that in my enemy folder. Remember, you can organize this however you want. It won't change anything. So I'm going to create a new object. I'm going to call this damage enemy. And we can go ahead and go into our object blue bullet, and we can add that new object as its parent over here. So now remember, our yellow bullet and our red bullet are both children of the blue bullet, which also means that they are ancestors of the damage enemy. It basically just means in this hierarchy, all of these things technically are also damage enemy. So if we go into the create event of our object blue bullet, and at the very top, call event inherited, now the blue bullet is going to get any creation code from the parent damage enemy. And because our other two bullets are inheriting from the blue bullet, they are also inheriting everything from object damage enemy in addition to all the stuff from the blue bullet. So you might be wondering, why are we inheriting stuff right now if there's nothing in object damage enemy? It's totally blank. Well, we're going to add some stuff, such as a variable called damage, so we know how much damage each bullet should be doing. But I say we take it one step further. I say we go ahead and add one more parent object to go above object damage enemy. I'm going to clear out my space real quick just so I can explain this. You might be wondering, why? What is the point of that? Well, we need an object that damages our enemy, obviously, and it needs to have children, and sometimes its children will have children, like this. But also, we need an object that can damage our player. We're not going to make that yet, but we will need one, because obviously we don't want the bullets that the player is shooting to hurt the player. Or maybe you do. Maybe your game is like that, which would be cool. But I think most people probably aren't making a game like that. So we're going to need to have two different damage objects anyways. So we can create a parent for both of them. That way all the damage objects in the game, whether they're intended for the player or the enemy, can share specific variables like the damage variable, all that kind of stuff. And once again, you have to think ahead to what kind of mechanics you want to have in your game. If you saw in the intro, they're crates that are little walls, but as you shoot it, they can get damaged until they break. And the enemies can also hit those walls until they can break. So if you have things like destructible environments that both the player and the enemy can destroy, or maybe you have some special type of enemy, like a big boss with a bunch of health that maybe it would be cool if the enemies could also damage that boss as well, then maybe you just want to check for any damage source. It doesn't have to be specific to the damage meant for enemies or the damage meant for the player. So really quick, let's just go ahead and add one more. And I'm going to right click and create object. And I'm going to call this O damage parent. And sometimes I'll do this and sometimes other people will do this, but sometimes people will put a P instead of O for object. I have flip-flopped on it on different projects, so I'm just going to do it this way right now. And now I'm going to make sure that I go back into my object damage enemy and set its parent as object damage parent. So now if I'm to go into the parent damage object and do a create event and create a variable called damage, and set that to whatever value I want. 1 is a good default one. Then now you can see my object damage enemy is automatically inheriting it because I don't have a create event in there already. And that means that the blue bullet, the yellow bullet, and the red bullet are all also inheriting it. Okay, so now we have this variable in all of our bullets, which is what we need to check right now inside of our enemy. So let's close these out. Let's go back into our object enemy and our step event. And now let's receive the damage. And we can do that super easily. So here we're just going to say if place meeting our X and Y coordinate of a object damage enemy, then let's run some code. So we have now confirmed that we are running into an instance of some kind of object that damages enemies. It could be a blue bullet, yellow bullet, whatever. Now we want to return the ID of that specific damage object that we're running into. So that way we'll be able to get the specific damage variable from it, and we'll be able to tell that object that it has already hit a target and it needs to be destroyed. So let's get that instance ID, and we can do that with an extremely similar function to place meeting. So first let's set up a local variable. I'm going to call it var underscore inst for instance, and we're going to return the ID with a function called instance place. And instance place functions extremely similarly to place meeting. So we put in an X, a Y, and the type of object we're looking for. And basically what this does is it also returns a true or false, but it also is returning an ID of the instance that it's running into. So when a specific bullet runs into the enemy, we now know which exact bullet that is, and we stored that here. So we can do this, watch. We can say take damage from specific instance. So we can just take our HP and we can subtract that specific instance's damage value. So now we'll lose some health, and we want the enemy to tell that specific instance. So we'll say tell the damage instance to destroy itself. And to do that, if you remember, in our bullets, we set up a variable called destroy that once it's set to true, it will destroy itself. So we can say instance.destroy equals true. Now we won't be able to see anything happening yet, so let's add a little draw event here. So I'm going to add event, add my draw event. Remember, we want to call draw self, so it still draws the sprite that we have here for us. We don't want it to be invisible. And we can also do this little function, just called draw text. It does exactly what you think. It draws whatever text you tell it to at a certain X and Y coordinate, and we're just going to draw it on top of the enemy. It's not going to look very nice, but this will help us see the HP. So we want to draw it at our X coordinate, at our Y coordinate, and then it asks for a string. And normally how you would type in a string is you would have 2 quotation marks like this, and now all this is just a string of text. So it would literally draw out these characters. But you can also change numbers into strings by using the function called string. And so if we just input our HP variable, then we're now getting a string that looks something like, since it's 10, it'll look like that. And then whenever your HP goes down, it'll look like 9, 8, 7, like that. That's basically all it's doing. So let's plop our enemy into the room, and let's make sure a lot of our setup is working. So I'm going to highlight my enemy down here, and I'm going to plop in a couple, and let's run the game. Okay, so I see my enemies, and they all have 10 health. And so now I'm just going to shoot a single bullet from the blue gun. There we go. And it's losing HP. and they could lose HP really fast if I shot it with the yellow one. Yeah, very fast. And with the red one, you can see I just kind of nicked it, but if I get really close, it can do a lot of damage. So pretty good. As you can see, there's a couple kind of weird things going on. Like, you notice how sometimes some red ones, some of the shotgun bullets kind of escape. Sometimes it's because they're just barely missing because we made our enemies very, very small. But you can tell sometimes they just don't hit. Now, there is an explanation for that, but that's going to be kind of a more involved fix that we're going to do later, and it's going to be a good bit more advanced. So right now, let's just take the win that we have, and the game is functioning. So let's just keep going. And now we don't want our enemies to have, negative 236 HP. We want our enemies to die. That's a quote to live by. So let's go back into our step event and add death. And this is going to be extremely simple as well. We just need to say if our HP is less than or equal to 0, right? So if our HP is less than or equal to 0, then we just need to get the heck out of there. We just need to be destroyed. So let's call instance destroy. Sounds easy, right? Well, it is. Let's test it. Look at that. Gone. 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 So easy peasy. Now, great. We have a very basic damage system working here. So let's just go ahead and move on to having our enemy just have an extremely, extremely basic AI. Let's just have the enemy kind of chase the player. Now remember, we need to be thinking ahead, all right? The greatest weapon you have as a game designer is to actually plan things out, okay? It will make your life immensely easier if you do your best to plan ahead. It doesn't mean you have to plan for literally everything, and it doesn't mean that you should never make progress on something because you're not sure if the thing that you're working on is gonna encompass every single little detail that you want by the end of the game. But just thinking ahead enough to where we can have ourselves be set up in a better place, right? So I have this object enemy here, but I also know that I'm gonna make more enemies. I'm probably not just gonna have a single enemy. Even if I have 2 types of enemies, that's still twice as much. And pretty much all of our enemies are probably gonna follow some same basic rules, such as most enemies, you want them to receive damage and you want them to die. That's just kind of how games work. Now, maybe some enemies you don't necessarily want to be able to take damage, but really that's more of a stage hazard. Even if it looks like a zombie guy walking around, if he doesn't die, then he's more of a stage hazard than an actual enemy. So as far as actual enemies go, they need to be defeatable. They need to be able to take damage. And so there's no reason we ever need to repeat any of this code for all of them. We just need them to all have this same code, right? And like we were doing with the damage objects, the best way to do that is to make sure we have a parent object for our enemies. And that parent object can house all of their shared code and the stuff that they would all need to have. And then the specific children enemies can have all of their special stuff that they need, like their special behaviors and all that. So maybe we only want one type of enemy that follows the player around, and maybe we want other enemies to stand still and like shoot or something like that. So instead of putting any following or movement code in this object enemy, let's change this to be object enemy parent, and now we can make another object here that is a child of this. So I'm going to create an object. I'm going to call this zombie. Every top-down shooter needs some zombies. At least pretty much every single one has zombies. And let's go ahead to its parent tab and make sure our enemy parent is selected here. So now it has its own HP variable. We can get the damage and death code from the parent and it will be exactly the same. And for now, we can go ahead and get the drawing code where it draws itself and it draws its HP as a number below it for wherever the X and Y coordinate are. So make a new sprite for your zombie. And for now, I'm actually just gonna duplicate this one. I'm gonna right click on my sprite enemy. I'm gonna go down to duplicate and I'm gonna call this S zombie. And then I'm gonna edit it really quick. I'm just gonna change its colors so we know that it's a different thing. So I'm gonna make it like green, make it like poopy green and light green. So there's our zombie. So I'm gonna go back in my zombie object and select the sprite for it. So that way we just know that it's different from the regular object enemy. And again, because it's a child and it's totally identical, if I were to just drop these in right now, they would function exactly the same way as their parent object does. So yeah, exactly the same right now. So let's add our special code to the zombies. So firstly, we want to add our own creation code to the zombie because we want to kind of do what we did with the player and what we did with the bullets. Remember getting our speeds and directions and using it to calculate an X and Y speed. You can do that for pretty much anything that needs to move in your game. So let's just go ahead and right click. We want to inherit the event because we want our zombie to still have the HP. And let's set this up just like we did in everything else. So we'll have a speed and we'll make it something low like 0.5. We need a direction, which we will be setting in the step event. So we just set it to 0. And we need our X speed and our Y speed, just like everything else. Cool. So we're done in here. Let's go to the step event. Same story. We're going to right click. We want to inherit the event because we want to keep our parent's code. And here's something we're going to do that's a little bit different. Because this code right here, like I said, on this line of code, it's just running everything in the original parent's event. So even if I put it way down here and I had other stuff up here, you know, whatever, this code would run after everything over here and before everything below it. So let's put it at the bottom because this is getting damaged and dying. That's what this code is. And the major thing I want to do here is once an enemy is dying, there's not really any reason to run any code after it. But also, since to get damaged, we are checking our position versus damaging objects, I want to check that collision after we've already moved the zombie. So the zombie moves into position and it's touching a bullet. I want the check to happen after both of those things. So I'm just going to put it down here. And now I'm going to say chase the player. So how do we do that? Well, our speed is already fine. Our speed is just that constant 0.5. But now we need the direction. And obviously, if we're going to be chasing the player, we want our direction to be going towards the player, right? So we can just use same function we've been using. So direction equals point direction. And we can use the enemy's coordinate, which is just the enemy's X and Y. And then for our second coordinate, we can use the object player.x and object player.y. So this will point us in the correct direction of the player at all times, no matter where the player is. And so now we just calculate everything like we did everywhere else. So x speed equals length direction x. We're going to use our speed and our direction. Y speed equals length dir y. Remember, I'm going to say it every time, but remember, if you're copy and pasting stuff, you shouldn't really be doing that because you can make errors. But if you are copy and pasting, make sure this says x speed and this says x, that says y speed, and that says y. Because if you mix them up, it's not going to work the right way. And so we're getting the speeds and we're moving. So x plus x speed, y plus y speed. And that should do it. Go back into your room, drop some in. I already did. So I'm going to put them kind of farther away from the player. And let's see. And look at that. They are now chasing the player. And they can take their damage. And they can lose. Excellent. I know it doesn't look like much, but this is actually very, very similar to the final code we're going to have. This is pretty much what was happening in the demo that I showed off in the beginning. It just looked a little bit fancier. So great. We're not quite done. Go back into your zombie, because here's something that we need to start doing. Anytime you are checking for another object's coordinates or another object's variables or something like this, you have to check and make sure that the object is actually in the room. The way we're going to handle the death for the player is we're going to destroy the player just like we're destroying our enemies whenever they run out of health. So that means if the player gets destroyed and the player is not in the room, GameMaker will have no idea what we're looking for. The GameMaker will not be able to find an X and Y coordinate for the player because there is no player. So we only want to run this code if the player is sticking around. So we need to say if instance exists, oh player, then we can get the direction. So now if the player is gone, the enemy won't look for them. So nice. The second thing is our enemies need to run into things like the player does. Right now, our enemies could just walk right through walls because there's no collision code. So we are going to do the same thing we did with the player, and we are going to add some collisions. And just like we did with the player, these are zombies that walk on the ground. They don't float or anything. So we don't want them to go over these yellow walls. We want them to run into everything. So we're going to do this exactly how we did with the player. So we're going to say if place meeting, we're going to check our x first, our x speed first. So if x plus x speed and y, and there's a collision with the wall, then we want to set our x speed to 0. Same as the player. Now we're just going to do the y. So yeah, place meeting at x, y plus y speed with an object wall. Then we are going to set our y speed to 0. Okay, again, make sure you're putting x speed and y speed in the right place. And let's check it out. So if I were to run over here, so that enemy's getting caught on there, that enemy's getting caught there, so they're getting caught on both of them. Great, easy. Okay, so they're ignoring the walls fine, but you can see they're kind of they're fusing. Okay, now they're just one guy. So we don't want the enemies to just collide with walls, but we also want them to collide with each other. So let's just add in enemies to this little check here. So if you remember, I said earlier, we want to be as efficient as possible whenever we're checking for collisions with stuff, and that's why we did the parenting stuff with the wall objects. But I also said at that time, I said sometimes it's necessary and sometimes it's just totally fine to do. And this is one of those cases. So now we can just add another check because we also want our enemies to collide with each other so they can't overlap like that. So now we're going to check our x plus x speed and our y with an object enemy parent. So any enemy. And let's do that down here too. So this should alleviate that problem. Oh, oops, that was stupid of me. Okay, hold on. I'm running on fumes here, so forgive me. These should not be ands, they should be ors. So to do an or, you do this right here, okay? Or you can write the keyword or if you want to. These mean the same thing. So like I said, I was just kind of on autopilot there, just putting in and. So it's self-explanatory. The enemies were only stopping if they were running into both a wall and another enemy. That's obviously not what we want. We want it to collide with walls and enemies, which means that they should stop moving if they run into a wall or an enemy. So now we can check. Yeah, okay, still running into walls, fine. And if I get all three of them over the edge here, then you'll see that they shouldn't. Yeah, they won't overlap like they did before. See? Great. Okay. I'm going to have these like I normally do. I'll label this real quick. Player's direction, all that. Okay, so now we have an enemy that can chase the player and it can get damaged and be destroyed. And the last thing I'm going to do is just add in my real zombie sprite. And I'll show that to you real quick. So here's my zombie sprite. He's just got 2 frames. And that's this kind of walking cycle thing. He's just kind of shuffling and being weird. I called him S Zombie Normal because I guess, you know, if you wanted to do like a recolor of the zombie that had different abilities, you could, you know, specify what type of zombie it was. So, but you see here at the bottom, I didn't put the origin between his feet. I kind of put it at the center of his head. So that way when he flips around left and right to look the correct direction, the whole top part of his body doesn't flap around this way. So then I just made a collision mask for him. It covers most of his body, so that way, you know, the bullets can damage him from pretty much anywhere. And now I'm going to add him to my zombie really quick. And I'm going to get rid of my placeholder, little sprite that I made. And so now you at least have real looking zombies. However, you see that? Yep, they're walking backwards. So we're looking pretty good, but they're walking backwards and they don't have the right depth or anything like that. So they're kind of drawing in random orders. So let's fix both those things really simply, really quick. So remember we used a variable called face to change the direction that our player was facing. Well, we can use that again here with our zombie, but instead of making 4 different sprites, 8 different sprites for it, we're just going to use it to say whether or not it's facing to the right or it's facing to the left. So that should be easy enough. So let's just put that in and we'll say face equals 1. So what we're going to do is we're going to be switching our face between 1 and -1. And we're going to be flipping the X of the zombie like that. So you can see here at our X scale, it's at 1. And if we changed our X scale to -1, my zombie's now facing to the left. So that's basically what we're going to do, is manipulate the visual of our X scale, our X flip. Okay, so let's go into our step event and let's find the place that we would be able to manipulate our face variable. Well, we can do this with a super easy check, and we can go right after we've gotten our speeds and say, get the correct face, and we can just check our X speed for it, right? Because if our X speed is greater than 0, that means that our zombie is moving to the right, right? So that means our face should be 1, which is the default, facing to the right. And that means if our X speed is less than 0, that means we're going to the left, and so our face should be -1. Easy. And if you want to clean this up, you can put this all on one line, which is what I'm going to do. That looks a little bit nicer to me. And then I'll show you the easy but slightly more dangerous way to get this working. So we can use the built-in variable of image X scale, which is that scale that I was showing you in the room editor here. This is our image X scale. So if I were to make it go up, it would get wider. If I were to make it go down, it would get thinner until he got negative and then he started flipping back around, right? So that's why -1 is just the same thing but facing the left. So that's our image X scale, and we can just set that right here and say our image X scale needs to equal our face, which will only be 1 or -1. So let's run that, and looks pretty good. They're turning to face me. They're turning the correct direction. And luckily, just having left and right facing sprite actually looks pretty decent in a top-down game like this. So cool, cool, cool. Now let me tell you one drawback about actually manipulating our image X scale. So the thing with actually manipulating this green image X scale built-in variable is this actually also changes your collision box, your collision mask in the sprite editor. So we saw that my zombie, its mask is basically the whole sprite, not all of it, but pretty much all of it. But if I were to do this and make him this way, the collision mask would be about this big. And that makes sense, right? Because if you think about the walls that we've made, that's exactly what we did there. This is just one object, but we've stretched it up and down. And you can see here, we've actually changed the Y scale of this one. And on this one, we've changed the X scale to be 8 and the Y scale to be 2 by dragging it around like this. You see? Hold on. There we go. And so if the collision mask didn't stretch with the visual of the sprite, then the wall would only still be here, right? So that's why it's a little dangerous, because if your collision mask is not perfectly centered, or if your collision mask is, for example, an odd number of pixels, whenever you switch left and right like this, it's going to shift the collision mask, especially if it's off center with the origin point. And like I said, if you have an odd amount of pixels, that's just going to happen. You're not going to have an even flip regardless, which means that if for some reason maybe you could get scenarios where an enemy is trying to chase you and he's pressed up against this wall, and his collision box, say, ends right here, and he's technically not inside of the wall. If he were to flip, the collision box could also flip, which might be a pixel off this way. So now he's 1 pixel in the wall, which means he's probably going to be stuck. So if you're like up here and then you get here and he turns to chase you, he might not be able to because he might be stuck. So we can get around this pretty easily, and that's just by using the draw event. Actually, let me go back. I'm going to go back out here. I'm going to clear everything out real quick. Okay. Cleared everything back out. So back in my zombie, instead of like hard setting this with the image X scale in the step event, we can actually just use a drawing function to change just visually what the zombie looks like. So let's add a new draw event. Now we don't necessarily want to inherit the parent event because we don't want the zombie to be drawn again. We don't want to use draw self. So let's just go ahead and override the event. So now we're not inheriting anything from the parent for the draw event. And let's use this function that we've seen before, draw sprite extended. Because remember, we did this to draw the gun, so it could actually change its angle. Because down here, we have rotation. But you see, we also have X scale and Y scale down here. So let's use that. So first of all, we want to use our sprite index, which is the sprite that we currently have. We want to use our image index, which is the sub image that we have. Our image index is basically, what frame of animation that we're on, and objects with a sprite set are already keeping track of that. So we just want to use these built-in things. We want to draw it at our X position and at our Y position. And now we're at our image X scale and our image Y scale. Now, instead of drawing the sprite to match with what its actual image X scale is, we can just draw its face instead. So you see what we're doing? We're totally bypassing having to set the image X scale, and we're just saying draw it the way that the face variable tells us to. Even though we're not actually changing the X flipped orientation of this character, we're just going to make it look like we are. So cool. We could just use our default image Y scale and our default image angle. Then we get to the color blending. Last time I said you could just do C white because blending with white does nothing. I'll just let you in on a little secret. There's a built-in variable called image blend, which is automatically set to white. So it's the same thing as just typing in C white. And lastly, we will just do our built-in image alpha. Now I could have just manually set this to 1, this to 0, this to C white, and then this to 1, so it would be drawn totally opaque. But I just wanted to show you that, for example, if I just put image X scale right here, this function is actually doing the exact same thing as draw self. It's just drawing the sprite of the object with all of the built-in information already. So basically, we just took the long form of draw self like this, and we're just changing this one thing. So anyways, This should look visually exactly the same as what we just saw, except now it's a little bit more mechanically sound. Yep, look at that. So they're turning, everything's cool, and they're definitely not going to get hung up on anything now. That is one reason, though, that you want to make sure that the origin point on your zombie sprite is centered in a way that you're happy with, and the collision mask needs to relatively be balanced around where the origin is. So for example, if the collision mask was just like here, the character's body would suddenly flip over here, but the collision mask is still just right here. You know what I mean? Because the collision mask isn't flipping. We're just doing a visual flip. So you still want to keep everything as centered as you possibly can, but this just avoids any of the issues that I was talking about earlier. So cool. The one thing we're missing from this draw event is the parent objects, drawing the HP. I mean, this is temporary anyways, but if you want to add it back in, you can just copy and paste it down here just so you can actually see it. I'm going to say draw self flipped the right way. Say draw HP, whatever, We're going to replace this soon with something that looks a little bit better. Just a nice little health bar. But anyways, yeah, that is a super basic enemy that you can fight and do all that stuff with. Okay, thank you for watching. Next time, we're going to sort of go over some of the issues that this damage system has and how we're going to fix them and how we're going to make a much smarter system. So be ready for that one. And yeah, that's pretty much it for this episode. So once again, special thanks to all my patrons on Patreon, and a super special thanks to Nixionic, Red Dragon Redemption, Null, Joseph Sandlin, Midnight, Jerica Deloach, Mark, AOGO, Homeless Bums Ahoy, Skelenthrax, Captain Ludwig, and Christian Donovan. Thank you guys so much, and I'll see you next time. Bye.